All right, guys, homework for 6.2. Let me help you out with this one. Let's go ahead and write our name, and let's go ahead and write our period as well. All right, so we've got a couple of different things we need to do here. It says for each table, there are 1, 2, 3, 4 tables labeled A, B, C, and D. We need to, number 1, circle function or non-function. And what they mean is down here. So for table A, we should circle either function or non-function. The second part of this is then write either the function rule, which is, starts with y equals, or explain why the relationship is not a function. Okay, so for purposes of the camera, I'm not going to keep going like this constantly. So I'm going to do it on a separate piece of paper right next to it, and you guys go ahead and fill out the rest of this table down here. So let's take a look at A. So we've got -2, 8, 0, 0, 2, -8, 4, 6, 8, and 10. Okay, first things first, we need to figure out if this is a function. Remember, if it's a function, then the x does not repeat itself. Basically, if I plug in a negative, if I push a button that says -2, I know I'm going to get an 8 out. If I put a 0 into this machine, I know I'm going to get 0'd out. If I put a 2 in this machine, I know I'm going to get a -8. So these don't repeat itself, so yes, it is a function. So if it's a function, we can come up with a rule. Now, we can't use the plus or minus thing for the output because it's 0, 2, 4, 6, 8. To use that little side trick, it has to make sure it's 0, 1, 2, 3, 4, 5, 6, 7. It can't skip any. Okay? So we've got to take a look at this. Let me give you a hint. If you see 0, 0 as one of your points, you know that this part, the plus or minus a number, doesn't exist. Just doesn't exist, because when I plug in a 0 here, I've got to get 0 out. So I can't add or subtract anything after that. So if you've got 0, 0, you know that it's just this part. Okay, well, let's take a look at it. To get from -2 to 8, I'd have to multiply by -4. Well, let's try that. 2 times -4, is -8. 4 times -4, -16. 6 times -4, -24. So what we have to do is this number y is always equal to the x times -4. So there's your rule right there. Y is equal to -4 times x. Your output is always your input times -4. All right, let's try B. So B says, fold this. So B says if I hit -3 or put a -3 into my machine, I get a 0. If I put a -2 in, I get a 0. If I put a -1 in, I get a 0. If I put a 0 in, I get a 0. If I put a 1 in, I get a 0. Okay. Well, it is a function, because if I push -3 or I put a -3 in my machine, I know for a fact I'm getting a 0. I could bet money I'm going to get a 0. If I put in a -2, I know I'm getting a 0. If I put in a -1, I know I'm getting a 0. Remember, the outputs can show up as many times as they want, but the input can only show up one time. And guess what? It goes in order, -2, -1, 0, 1, 2, 3, so we can use that side trick to help us. So let's set it up with y equals some number, x, plus or minus some other number. Okay? Well, I mean, this doesn't change, so it's plus 0 every time. So we're going to borrow that number, and we're going to multiply it by the x. Okay? So we've got 0x. Well, if I plug in a -1, -1 times 0 is 0. I'm supposed to just get 0. So you don't have to add or subtract anything. All it is y equals 0x. Because watch, if I put a 1 in, y equals 0 times 1. Well, that's 0, so y equals 0. That's what we're supposed to get out. Let's try this one by putting in a 3, and I should get out a 0. If I replace x with a 3, 0 times 3 is, so you get 0. Check. Well, 0 times anything is just 0, right? So although mathematically this is correct, algebraically, when you're talking in algebraic grammar says that you just have to say y equals 0. So there's the rule for that one. Anytime you put in, well, I don't care what it is, you put in anything you want for x, you're getting 0. So y is just always equal to 0. Let's take a look and pause and see if that makes sense. Is y always equal to 0? Yep. So that's it. So yes, it is a function, and the rule is y equals 0. All right, let's try C and see what we get. Okay, so if I put in a negative 100, I get out a 10, that works. If I get out a negative 25, I get out a 5. If I get a negative 4, look at this. If I push negative 4 as a button, or if I put negative 4 into this machine, can you bet money on what you're going to get out? I hope you don't bet on this one, because if I put a negative 4, I've got a 50-50 chance of either getting a 2 or a negative 2. Those are not the same numbers, so this is not a functioning machine. This is not a function. If I hit that button, I don't know whether I'm going to get a 2 or a negative 2. I cannot predict it, so it's not a function. If it's not a function, we don't have to come up with a rule, but we have to explain it. So the input of negative 4 results in 2 different outcomes. Therefore, it's not a machine. All right, next one over here, D. Well, let's take a look. I've got negative 312, negative 212, negative 1. Do I see any of these guys that repeat itself? Nope, not at all. Okay, so it is a function. I can absolutely predict what's going to come out when I put in a negative 3 and what's going to come out when I put in a negative 2. So yes, it is a functioning machine. Now, let's learn from this one that we did over here. If my y is always 0, I ended up with a rule of y equals 0. If my y is always 12, I'm simply going to end up with y equals 12 all the time. There's the function. What really happens is, let me show you the long way. Because this is in order, 0, 1, 2, 3, there's no skipping, right? Negative 3, negative 2, negative 1, there's no skipping. So I go up by 0 every time. If we borrow that number for a moment and multiply it by the x, what I end up getting is 0 times x. Well, if I plug in a negative 3, I'd have to add 12. If I plug in a negative 2 times 0 is 0. I'd have to add 12. If I plug in a 0, 0 times 0, 0. I'd have to add 12. So I'd get that my y is always equal to this number times 0 plus 12. Well, 0 times anything is really just 0. And so you're just left with y equals 12. All right, so we got through that part. We've got another page on the back, which I'll do in part 2.